All right, let us continue with our rational expressions. Today we're going to be multiplying and dividing rational expressions. So again, we're going to take a look at rational numbers. So we can employ the same processes to multiply and divide rational expressions. So let's, as a quick reminder, what do we do when we're multiplying rational numbers? What I'm going to do is I'm just going to factor. There it is again. I keep on saying the word factor when it comes to fractions. So I'm going to factor 63, and that's 3 times 3, right? 63 is 9 times 7, I believe. Divided by 35 is 5 times 7. So what we can do, this is a product. So if you want, we could put this all together, or we can simply, because if we put it all together, this will be, we multiply the numerators, 7 times 3 times 3 times 7, and the denominator would be 3 times 3 times 5 times 7. Oh, yeah, okay. Yeah. And then we can start crossing off factors. But instead of putting it together all like that and cross off factors, what I can do is recognize that we have a product. And I'm going to cross off common factors that are both in the numerator and the denominator. Well, immediately I notice that 63 over 35, there's a factor of 7 in both numerator and denominator. So I can cross that out. So it makes the expression a little bit simpler. And then I'm going to take a look. I notice I have a factor of 3 here and a factor of 3 here. So I'm just going to cancel those out. A factor of 3 here and a factor of 3 there. There we have it. So if there exists a factor in the denominator and the numerator, you can cancel out that factored pair. Well, what factors remain in the numerator? Well, we have a factor of 7. What factor remains in the denominator? We have 3 and 5. So believe it or not, this is 7 over 15. Think about how you may have approached this in the past. You would have had to multiply the numerator with the numerator, denominator with the denominator, and end up with a much larger expression. Let's go on to the next example. So it's 4x squared. So I'm just going to maybe write it as 4x times x divided by 3xy. I'm going to multiply it by y cubed, and that's y times y times y, divided by 8y. So instead of maybe writing 8, maybe I want to write 8 as 2 times 4. And the reason why I would do that is I recognize that there's a factor of 4. Wouldn't it be nice if there was a factor of 4 in the denominator that I could cancel out? So allow me to start. So 4x squared divided by 3xy times y to the power 3 divided by 8y. If I factor the expression, I just cross out pairs of common factors. So the factor of 4, factor of x. Now, what I recognize is that I have some y's in the top and some y's in the bottom. So factor of y cancels out with a factor of y. And in fact, I have a factor of y over here and a factor of y there. So what is left in the numerator? I have a factor of x and a factor of y. And in the denominator, it's 3 and times 2. So it's xy over 6. Now, you may be noticing that I'm leaving it as the factors of 3 times 2 and not as 6. I'm doing that in preparation for how we think about polynomials. So maybe let's multiply. And we are going to state our answer in simplest form. We're going to identify all non-permissible values. By the way, I forgot to put my non-permissible values for the previous question, so let me go back. So x cannot be equal to 0 and y cannot be equal to 0. there and right there, right? You can't have any factors that, or any denominators that are equal to 0, so those are the values. All right. You may want to press pause and factor. So factor all these polynomials. So press pause, give it a go. What we see is that this first one, a squared minus a minus 12, is factored into a minus 4, a plus 3. The denominator, a squared minus 9, is the difference of squares. So I factor it as such. Now on the left-hand side, I'm going to take a look at this numerator. I'm going to factor that numerator. So a squared minus 4a plus 3 factors. I'm going to use the product sum because the coefficient of a squared is 1. Now in the denominator, I'm going to factor the denominator of this expression. So it is the greatest common factor of a, and when I factor out a, there we have it. So right away, I'm going to identify my non-permissible values because everything's in factored form. So maybe just so that I have some means of talking about it. So from the green one, I get my green factor, I get a cannot be equal to positive 3. From the yellow one, I get a cannot be equal to 3. From the factor of a, I get a cannot be equal to 0. And from the pink factor, I get a cannot be equal to 4. So these are my non-permissible values. There's many of them, one from each factor of the denominator. Now, I'm going to start by crossing off common factors. We have a common factor of y minus 3. All right, I'm going to search for some more. Does there exist other common factors? Sure. Y minus 4. Sorry, a minus 4. Does there exist more common factors? Sure. A plus 3 are common, so I'm going to cross those out. What is left? Well, what is left is a plus 1 all over a. So this mean expression simplifies into a plus 1 over a, and that is a final example or final answer. So do not simplify anymore because the factor of a plus 1 is a different factor than a. All right. So far, so good. Next example. D over 2 pi times 4 pi x over d. So I have I'm just going to maybe write this down. I would presume that d is the only variable here, whereas pi is a number. Agreed? I hope we can agree on that. And 4, the only change I'm going to do is I'm going to write 4 as 2 times 2. Because I see that there's a factor of 2, and it sort of sparks my brain that I may want to cancel out common factors. There we have it. All right, let us begin. I'm just going to simply start by denoting that d cannot be equal to 0. Fair enough. I'm going to ask myself, does there exist factor pairs in both numerator and denominator? Sure. D and d. 2 and 2. Pi and pi. So that whole expression just quickly simplifies into 2x, where d can't be equal to 0. No, x can be equal to 0 because it's in the numerator. Moving on. All right. So again, I'm just going to have to do a lot of factoring here. You may want to press pause and do some factoring because I can do this fairly quick. So press pause, factor away, see what you simplify to. So first, I'm going to factor the numerator, and the numerator factors to 2x plus 1 times x minus 1. and I have the factor of x plus 3 in the denominator. On the left hand, the expression on the left-hand side, x minus 9, I notice that's a difference of squares. So that is going to be x minus 3, x plus 3, divided by 2x minus 1. Please be careful with this. So I'm just going to list my non-permissible values. That from this term, I can say that x cannot be equal to negative 3. From 2x minus 1, I get x cannot be equal to a half. So these are my non-permissible values. And now I'm just going to cancel out factor pairs. So x plus 3 cancels out with x plus 3. Believe it or not, those are the only pairs that are common. 2x plus 1 is a different factor than 2x plus 1. So those don't cancel out. So I'm left with 2x plus 1, and I keep the factor of x minus 1. We still have a factor of x minus 3. And then in the denominator, I have a factor of 2x minus 1. And keep in mind that my non-permissible values are still going to be x cannot be equal to negative 3, comma, 1/2. So the process here, what you're going to do is you're going to factor both numerator and denominator. Next, please identify your non-permissible values. I will look for you stating them. However, the identifying the non-permissible values is a very, very common step that is missed. We're going to express the numerator and denominator as products of factors, but we're not going to multiply them, and we're not going to we're not going to multiply them. Also, what we're going to do is we're going to eliminate common factor pairs among the numerator and denominator, just like what we've been doing.